Hey, are you a business owner, entrepreneur, or professional? If so, we want you to apply to be a featured guest on our show. My name is Adam Torres, and I host the Mission Matters series of podcasts. I've recorded over 3,000 episodes, and we are just getting started. How do you know if you'd be a good guest to be on the show? Well, only one way to find out, and that's to apply, but I'm going to let you in on a little secret. We want guests that have a story to tell, guests with a brand, a product, or a service that can benefit my audience of listeners. If this sounds like you, go to missionmatters.com and click on Be Our Guest to Apply. I'd love to talk to you and get to know more about your story. Again, head on over to missionmatters.com and click on Be Our Guest to Apply. All right, now let's get into the show. Hey, I'd like to welcome you to another episode of Mission Matters, your source for all things business. My name is Adam Torres, and if you'd like to apply to be a guest on the show, just head on over to missionmatters.com and click on Be Our Guest to Apply. All right, so today I have Edmund Burke on the line, and he's founder and CEO over at Space Information Laboratories. Edmund, welcome to the show.
Thank you, sir.
All right, so I'm excited for today's episode. Over Edwin's right shoulder, you see all of this amazing technology that we're going to take a look at. We're going to look at some of his original VBITS technology, with his original patent, I should say. And he's got some interesting things to share about how this technology is going to be used. But Edmund, before we get into that, I do want to kind of get the backstory on how did all this get started? Like, how'd you get into this being really a space entrepreneur?
Yeah, I started my career actually out of college. I went to Virginia Tech, and then I got recruited to Vandenberg Air Force Base, which is an Air Force space and missile country in Santa Maria, California, close to it. So I started there, and then I became an Air Force program manager. And during that time, I had this idea to kind of transform, the space business. And it started with the VBITS technology, to do autonomous flight termination in space-based range. So, and I'll talk about that a little later, but that kind of pulled me out. I kind of had a guaranteed paycheck for life, but I decided to start a small business and do my passion and make it happen.
Wow, that's I mean that takes guts, just throwing this out there. So like starting a small business is not easy, number one. I mean, and so when we hear about like things like, when I think start a small business, I think, start a restaurant, start a printing design, but you entered the space industry.
Yeah.
I mean, what kind of, and not saying there's any magic formula here, but there's others that are listening right now. We are in the renaissance of space right now, in space technology. What kind of advice or tips would you just give to maybe some of those young budding entrepreneurs that are just getting started, that want to kind of want to play in the game, but it's not easy?
Yeah. I mean, it really takes, innovation, the idea. When you're young, you don't know everything, all the mountains you have to climb. And I'm glad I didn't know all the mountains to climb, but in the space business, you first start with the idea, and then you invent, but then eventually you have to end up building it, manufacturing it, testing it. And there's a lot of regulations and quality control. So as the company still started out as a premier design house, but then we became a manufacturer of our technology, for the big primes like Lockheed Martin and others now. And so there was a lot of, process procedures we have to put in. We're an AS9100 quality management system company, which is a big mountain to climb. When you're working with the government, you have a government accounting system. Every penny matters. It's very detailed. It's very good, actually, what they do. So, U.S. taxpayer, you're trying to make sure the U.S. taxpayer money is wisely spent. So that's there's a lot of things you have to put in place. But I don't want to discourage any entrepreneur with a good idea, a young idea. That's how I was, and I sprung out, and it worked out. But it's not for the faint-hearted, but you can make it happen if you believe in it, and it's really good. And then you have to convince others that it's good technology, and then there's a lot to that, writing a lot of proposals, which is my main job as a CEO, to keep people employed. And so that's what I encourage people to pursue their passion and vision.
Oh, this is great. So I want to get into some of this technology, but maybe just give us an overview of SIL overall, just as a company. Tell us a little bit more about SIL.
Yeah, sure. Yeah, we're a avionics and power system company. along with, we have a new product for nano microsatellites, which is a small sat revolutions happening, as you know, today. So those are the main areas. We're a full AS9100 quality management system company because we supply hardware to like Lockheed Martin and other prime contractors in the Department of Defense. We also supply now to commercial space, like Firefly is going to launch their first rocket from our hometown, Vandenberg, and our batteries are powering everything on that vehicle. So that's we're working in both domains, Department of Defense and commercial space.
Wow, this is a big deal. This is exciting. And without further ado, I want to get into some of these products and the technology and what they're being used for. So let's start off with VBITS, which stands for Autonomous Flight Termination System and Spaced Base Range. Let's start with that. Tell us a little bit more about VBITS.
Sure. Yeah, I have some of the technology on the table. So I'm really proud to show this. This is VBITS number 1, 1998. I built in my garage in Santa Maria. So this actually was pioneering probably like 20 years in advance, but the VBITS technology, to give an overview, the way rockets, launched from Vandenberg Air Force Base, we tracked them with radar. We terminated them with a man in the loop looking at a screen, pressing a red button, sending commands to the rocket. Okay. And we also have telemetry systems on the ground to bring the telemetry data from the rocket so you can see what's going on in a rocket. Well, I realized technology, GPS tracking, GPS technology, which came from the Air Force, actually from the Navy originally and the Air Force, that transformed everything in our world, driving cars and everything. So at that time, I decided to put together a unit that combined not only, this actually started my power battery technology. It had lithium-ion polymer battery. It had a GPS tracking module, a satellite comm went through Globalstar, which is these modules, also S-band transmit downlink and processor and comm all in one unit. So basically you mount that system and you need no other ground assets at all to track, destroy, and send high-speed telemetry from that vehicle, okay? So you basically eliminate a lot of the ground infrastructure. So every launch you save, at least $1 million a launch if you can do that. So that was socialized because it was like probably for like 15 or 20 years. And now the Air Force has totally embraced and said, we are going to autonomous flight termination. We will pursue space-based range. And the 4 stars basically wrote letters now saying the industry will go this way. So an idea like that. So we're at the epicenter of making that happen. The first units I got, they couldn't see all this. They just said, Edmund, I just need a GPS tracking. We need to be able to do GPS tracking on rockets first, right? And then the next, and then it got on actually a DoD program, and then it got on ULA, Atlas, and Delta rocket. Okay, and that started in the GPS tracking. And then Elon Musk decided he went and did autonomous flight termination on his vehicles. He saw that the thing that was happening, so he actually implemented that. And others are now implementing it, and we're also involved. And we just actually, this hardware right here, this is the VBITS autonomous flight termination unit. This has a power module, a sensor module with GPS receiver and silicon MEMS IMU, and a processor and comm. So this will fly on a DoD mission. We're range safety space qualifying, and will fly on a DoD mission of national significance in 2022. So this is and we built many of these VBITS along the way, but this is a new, and this is all modules, stacked modules with Faraday cages. So we can add a satellite comm modem in here. So we basically, track, destroy, and send high-speed telemetry Ka-band to satellite, which is Ka-band revolutions happening. Starlink, Jeff Bezos' constellation is going up. There's also Viasat, which we could sit in JetBlue aircraft and get 15 megabits a second as we're flying on JetBlue. That's because there's Ka-band satellite revolutions happening. So all that can be integrated in these small boxes now, and do this. Okay, so that's where I saw the need, the mission, and also it saves taxpayer money, right? So there's a combination. So that's kind of a little bit on VBITS.
Wow. So, I mean, I'm just thinking back this and I'm just sitting here, mind blown. So, and this started in your garage. You said the very
Yeah.
first
A lot
prototype.
of things start in people's garages. People don't realize, but usually it's an innovation that pulls that person with a mission, and
Yeah.
then you're driven to do it, right? And unfold that. So it starts with a good idea, and then you have to, building a business in aerospace is not easy because it's very quality control. It's like the closest in quality control is medical industry to aerospace industry. If obviously for human bodies, the machines cannot have a problem when you're working on a human body, but it's very equivalent quality control. So.
Oh man, I mean, what a story! Let's get into it. Let's get into another product. So let's move on to Sil's game-changing lithium-ion polymer IntelliPack battery. So how did this come about?
Yeah, actually, the first battery I had in my VBITS unit, and I wanted to make sure that power system was in that unit, but it ended up that I started working with lithium-ion polymer cells when it first came out in like 98, 2000. And it's in your iPhone. So I said, there's very little electrolyte to leak, and I wanted to make sure to use something that was really safe. So we ended up working with that. And then I ended up developing, it's really about lithium-ion batteries, they're very highly energy dense, so you have to keep them safe. So we ended up working on intelligent power systems where you have a battery management system in the battery. So, when you're charging the battery, you can't over voltage charge it. When you're discharging, if there's a short circuit out there, then you want to make sure the battery, opens up and doesn't, discharge in a short. So this BMS is at the heart of an intelligent battery management system for lithium batteries. We made it really user friendly. So an Air Force airman can utilize the battery with a Windows GUI and data logger. So you can see exactly all the cell voltages in the battery, the temperature in the battery. So at the heart of it's intelligent power systems. So here's a little battery here. This is a 2 amp hour. In our world, it's 8 cells stacked. 8 cells times 4.2 volts fully charged is 33.6 volts. That's an avionics battery that goes on rockets, launch vehicles, satellites. It's usually 33.6 volts. So this is a sample of a 2 amp hour. And we've scaled it from small batteries like this, which is a 2 amp hour battery, which that's the battery brick. That's what you see. This goes in, and then the BMS slips in the front that I showed you right here. This slides into the case from the underside, and it goes in just like that. See, inside, and the battery pack goes in there. And then you have and we have to make it work in extreme, thermal cycle, vacuum, shock, vibe. We've learned how to do that, to package this in a way that can survive in space, and also the launch vehicles. It ascends, it shakes, and then the second stage blows apart, and it's like a bomb going off next to the battery. It has to survive that and keep working. So there's a lot of engineering. I call it, my first VBITS had engineered for space on the top right here. It's engineered for space.
That's awesome.
So there's a lot of engineering's humbling. Okay. You can design and have the best design engineers, but you have to test it to death, and you learn things after that. And so you keep refining it, and it's an endeavor. Okay. So, and I'm really proud of this battery right here to the right. This is a 52 amp hour, and it's going to fly on for nanoracks. They contract with us to power their spacecraft and their high power. There's a high power cutting tool, Maxar, and they're going to demonstrate they can actually modify second stages in space, so they reuse them. It's because the second stage just floats in orbit, but you can go up to and reuse them, go up robotically, put things in them, cut metal slices and modify them and reuse them. So nanoracks is going to launch their spacecraft in June. This battery powers their spacecraft and the high power cutting tool, which is revolutionary, this technology, because it can discharge very high current. Also, so the spacecraft needs not too much power, but then that high power cutting tool, metal cutting tool comes on, it needs 2,000 watts. Or if you have they're pulling off for small satellites, we're putting SAR radars in there. And the spacecraft has a certain amount of power, and then the SAR radar comes on, and it draws 5,000 watts. And so you need a battery that can do that. And we pioneered that.
Wow, that's that's amazing. And you have me wanting to be over there with you right now. I'm like, why isn't this an in-person interview? I want to grab these things too. Like you showed the camera, and I'm like, I want in too. I mean, it's quite amazing. And I see how and one thing that I see, and it's just very obvious, is when, sometimes when we're looking at what it takes, for the general public, myself included, we watch a launch, we watch something else. We don't think about all of the steps it takes, all the stages it takes, all the things down to the battery, where it's taken, since I believe you said 1998, you've been working on this and perfecting this, and every component it takes to make that successful. I think sometimes we maybe underestimate that a little bit.
Yeah, definitely. Yeah, the power is everything. If the power system fails, everything fails in the launch vehicle or the satellite. So it's really critical. The Department of Defense, the U.S. Air Force, the people are realizing this, and they're really starting to focus on this now. So that's great. We've been recognized. Actually, we were in the Air Force Works Engaged Space Challenge, and we were selected. There was 800 companies entered, and SIL got selected.
Wow.
And we're working with the Space Force now and SM Space and Missile Center in LA, Air Force Base. They recognized us. So we're starting to get out there, and I really appreciate, you interviewing me so we can show some of this to the world. We do all this work, but we really can't show it or even talk about it, what the reasons of why we're doing this, and how we're doing it. So there's always a need, right? You have to have a need first. And then, obviously you're on a mission and you have need, and then things start happening, right?
Mm-hmm. It's awesome. All right, let's move on to another development. So Chameleon 12U to 27U nano micro satellite technology. Let's get into this one.
Yeah, this is our latest technology. You can see back here, what I did is I ended up making a stackable satellite with modules, like Lego for satellite. And you can 3D print these 3D printing machines now. You can 3D print all day long. So it ends up, let me pull forward a couple of the modules. You can see the 3D printed model. So you see a satellite, solar panel in the back, power module with your batteries, comm module so you can send data down from the satellite, your attitude control module so you can orient the satellite in space, and then the CNDH is your brain, your computer has to be running the satellite, right? So what I ended up doing is I designed this stackable modules. Each module is a Faraday cage, okay? So it stacks down tongue and groove down, and so you can basically if you have different missions, you can put different modules in. So once you qualify it, you don't have to redesign the whole satellite. So it ends up being a stackable Lego for nano microsat. The CubeSat revolution, most people have heard, came out of the university world, and there's a whole revolution going on to put nano microsats in space for all kinds of things. So I ended up making this really easily to make and also test. You can test each module and stack it down. It's totally reconfigurable. So I called it a chameleon. How could I describe this? A chameleon is totally adaptable, right? It can change colors. It can adapt to its environment. So I decided to give it a bigger vision of if a couple hundred engineers could work on this, we could have totally, computer systems that are totally recognized and swapped to the next computer system internal to it. So it can advance as technology advances. This thing, it's a totally flexible nano micro satellite, open, modular, scalable, and reconfigurable. Okay, I call it OMSR, open, modular, scalable, reconfigurable. So that's a lot. It also just so happens that the Faraday cages, even in an electromagnetic pulse environment, this thing could fly right through that because of the Faraday cages inside the modules. It's sealed aluminum Faraday, and that also helps you to pass all your space qualification. We have to go through electromagnetic interference. That's the hardest test, where you radiate this thing, and it has to still work in those environments. Obviously, you have a vacuum of space. It has to work in that environment. There's a lot of, as you go around the sun, your Earth and sun, it gets hot. when you're in the sunlight, and when you're out of the sunlight, it gets cold, just like that. We're spinning 1,000 miles an hour, right? When you're on the satellite, every 45 minutes you're in the sun, and then the next 45 minutes, 50 minutes you're in not in the sun. So all that stuff. Satellites are really fun because you have to think about all this and make it work in that environment, which is really it's really great. We live on Earth here. The environment outside our atmosphere, it's a pretty tough environment. So
I think that might be an understatement. It's great we live here on Earth, but what are some of the potential uses of these microsatellites? Like, what are some things that how you can see them being used?
Yeah, I mean, there's a lot of people working on this. You use them for imaging, right? That's natural, like Google Earth. That's where the images are coming from. So you can see all that on the ground, like exactly your house and, the commercial part of that. So the imagery. There's other communication is another one, so you start working with small sats, and you can directly link from your cell phone anywhere on the planet, right? Direct to the satellite. So, so you can be anywhere on the mountaintop and you can communicate. So that's starting to be worked on. There's things like fire in California, be able to actually look at the vegetations in the hills and predict where, fire is going to break out by looking at those areas and doing a vegetation index, looking at how dry it is exactly in certain areas. You can image that and see that. So those are some of the commercial applications. Looking at carbon. I mean, we have this whole carbon issue, global warming. We're starting to map out. There's actually NASA did carbon observatory, orbital observatory that actually launched out of my home, out of Vandenberg. A couple of them did. And people are working on that to actually look at all the carbon footprint, like where all the outgassing is coming from is usually dumps, right? Like all over the world, we're outgassing out of that. We're figuring out where this is coming from. So those are a lot of the applications. It's endless. It opened up a Pandora's box, and there's young engineers and people that are thinking about all kinds of ideas to use nano microsatellites, small satellites. Now it's a whole revolution. Yeah, it's the golden age, as you said. It's unbelievable what's happening. It's like when the railroads got built. Yeah. And a lot of the billionaires moved in, right? They come in, right? Jeff Bezos, obviously, and others. But there's a lot of the small businesses in this aerospace business are leading the way, okay? Because we're the pioneers. All the small businesses are out there too. The DoD is starting to learn how to work with us. They're really trying to engage now, which is really great. Like Air Force Works, they just stood up Space Works. They're starting to try to reach out to us, to the innovators, and so anyway, that's a little bit about that.
Yeah, I think the press normally, and I think the general public normally just get, the idea of like, to be able to go to space or to go to Mars or these type of things. But I think it doesn't get mentioned enough. What you said, of course, about the small businesses behind making these things possible, but also just the functionality of us exploring space and us sending these technologies, things like using our phone for, Google Images and all these things. Like, that's where it's coming from. I don't think people, think about that enough.
Yeah, exactly. And GPS, obviously, look at what GPS, there's satellites in the sky. We actually have, navigate to, and we get right to where we need to go. It's such a great thing. I don't know what I could do without my navigate to on my phone.
I can't.
I mean, it makes your life so easy. So there's thousands of applications that are starting. People a good idea, and then they start implementing it. So it's a small sat revolution. There's also a communication revolution happening, all simultaneously. So we're utilizing that, the best of the technology, and then our technology is totally open and reconfigurable. So as technology evolves, we don't want to have a black box syndrome where we build this black box and it cannot be upgraded. I tell my engineers, I do not want that. I really insist on it, that the way we develop our technology is all that way. Everything in here that I'm showing you is flexible, modular, reconfigurable. So that's a key component of what separates SIL from others. You know, you have to have a discriminator. So that's anyway.
I like to switch it up a little bit, Edmund. So we've talked quite a bit about technology. We talked about, you know, the inception of SIL, your background. I mean, all of this. So SIL wouldn't be possible without obviously education and specifically STEM education. And there's a lot of, you know, debate about what's going on and how America may be lagging in some of these areas, especially in the K through 20. I mean, what's your feeling on just education overall in this STEM area?
Yeah, it's really critical. Our youth and get inspired to go into space applications, aerospace, or any type of engineering, science, technology. You know, across the board, medical, aerospace. You know, we need more people studying, you know, science and engineering and math. Our competitors, you know, China, they're out. There are many more of them studying those degrees than the United States. So we're falling behind there. And that's critical. You know, we have to compete on a national level, international level for technology now. I mean, that's the way the world is. So it's very important to get a very good education. You know, space is a great thing because it inspires you. You know, look at the image behind me. I mean, this is the most famous image of looking back at the Earth, and each person, you know, their potential is given by God, and it's a shame if they don't reach their highest potential, or they get so involved in society and it crushes them down, whatever, and they don't blossom, and they're in hard. You know, we have sometimes hard environments we're in, but every individual can break out of that chain, you know, and believe in themselves, and so it's very important. When I first started, before I started SIL, I started a nonprofit, Endeavor Center, was dedicated to STEM education for youth and teachers. And I always try to give back. Okay. A lot of those ideas when I was young, when I started a nonprofit, a lot of the ideas I had SIL when I was young, I'm just making them happen now. Okay. They're all entering my brain at a young age, and I'm just unfolding them. Okay. And so, it's very important. It's the most important thing to empower a human being on this beautiful blue ball. And we're only here a very short period of time. We're not here very long. As you get older like me, you see your family, your mother and father getting older, and they pass away. You realize how short the existence is. So that's what it's all about, giving back. And by the way, I want to show this because the Air Force, you know, one of the core values of the Air Force is service before self. The military understands that. So that's why I wear the American flag I'm wearing today and the Air Force pin.
It's wonderful. Edmund, well, first off, I just want to say it's been an honor having you on the show. I love your message. I love what you're about. I love that you're representing small businesses in the space industry, and that you're a living testament to what it takes to make some of these ideas work. You know, years later, starting back in 1998, and you are making a big difference. So, and it takes so many people to pull off what's happening right now in space and in space technology. So, just want to say thank you for coming on the show. And to the audience, as always, thank you for tuning in. If this is your first time with us, make sure you hit that subscribe button. We have more great guests coming up just like Edmund, and we definitely don't want you to miss out on those. And Edmund, thank you again for coming on the show. It's really been a pleasure. Last thing I'll ask is if somebody wants to learn more about SIL, or if they want to follow up and follow your work overall, what's the best way for them to follow up?
Yeah, you would go just to my website, www.spaceinformationlabs.com, www.spaceinformationlabs.com. I'm also on LinkedIn. You can just look at Edmund Burke, and you can just put it in there and say, hey, connect with me, and I'll connect with you. And then, I also post a lot of our technology. We have a SIL LinkedIn site that we use, but I also, at my personal one, I post a lot of our technology as we achieve something. I only post what we've done. I'm not a believer of posting some future thing. I always post like what we've actually achieved. I really believe in that in marketing. Don't oversell, but put things that we've really accomplished. It takes a whole team of engineers, technicians, assemblers. It's just not me. I'm the visionary leader, but it takes really great talent behind the scenes, and they're the true heroes. Okay. So anyway, that's how you can follow Space Information Labs.
Awesome. Edmund, thanks again for coming on the show.
Okay. Thank you, Adam. Appreciate the interview. Great.